Hello Algebra 2s and welcome back to Unit 11. This is day 2, graphing logarithms. If you're following along with eMath instruction, it is his Unit 4, Lesson 9. Okay? So, we have done all these graphs and their inverses. We did them all yesterday. We did them last unit as just exponential graphs. Okay, so now we're going to see how that inverse applies. So yesterday we did it with a base 2. Today we will do it with a base 3. Okay, so the second you see this, that you have to graph a log, okay, you are going to construct a table for the base of that to the exponent, which is technically its inverse. Whoops, sorry about that. Okay, which is its inverse. So we know these 3 points are the most important because anything to the negative 1 is going to be its reciprocal. Anything to the 0 is 1, and anything to the first is itself. Okay? And then we have 3 to the second is 9. 3 to the negative second is 1 over 9. Now, in order to graph a log, we just take these xy values and switch them so that the y becomes the new x and the x becomes the new y. Okay, so all of those x values are now our y values, and all of our y values are now the x values. Okay, so it says to graph both, so we know graphing 3 to the x is 0, 1, 1, 3, and mark the 3, 2, 9, 4, 5, 6, 7, 8, 9. And then it goes to 1/3, 1/9, and it gets closer and closer to the asymptote, which is y equals 0. So here we have it. Of course, you should be graphing in pencil and label y equals 3 to the x. Now to graph the log of that, you're going to do the 1/9 and 2, negative 2. It's easier to start with your whole numbers. So write 1, 0, write 3 up 1, write 9 up 2, and then start to do your fractions. Okay, so 1/3 of the way goes down to negative 1. 1/9 of the way goes even closer. That's that asymptote. It's getting closer and closer, but never touches. Okay, and then it goes on. So as it comes down, if you notice now, it's a vertical asymptote, and any vertical is x. So the asymptote is now x equals 0. And then we follow this along, graphing with an arrow. My pen is not working today. And label it. Okay, so we graphed them both, we labeled them. Look at our domain and range, just like your domain and range in the lesson today with a base of 2. Any exponential without any shifts. This exponential is going to go on to the left, which is our negative domain. And as it goes up, it's going to the right. So our domain is negative infinity to positive infinity. Yet it's asymptoting at y equals 0, which means it can never be 0 or negative. So that is 0 not inclusive to infinity. Okay? So those are both interval notation. Set builder would be x is an element of all reals, or y is greater than 0. Okay, that's that set builder notation. The log graph is going down on the y values, and as it goes right, it's going up on the y values. So that's a range of negative infinity to positive infinity. But if you notice the x values, the domain, it had a x equals 0 asymptote, which means it can never touch or cross this. It's only on this side. So that's 0 not inclusive to infinity. Do you notice how they swapped? Because we said anything that's reflecting on that y equals x is an inverse. And the x becomes the y becomes the x, okay? So both of those were interval notation. This would be x has to be greater than 0, and this is y is an element of all reals, okay? All right, now, it states to do this in your calculator. Y equals log base 10 of x, which you know is a common log, and they don't even have to write that 10 there. We discussed that today in class. So if you think about this, just work backwards. This is y equals 10 to the x, negative 1, 0, 1, 1/10, 1, 10. That's last unit. Now graph this one. Switch your x and y. 1/10, 1, 10, negative 1, 0, 1. Okay? So if this is to 10, about here maybe 5, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, so 1, 0 is here. 10, 1, well, if that's 2, that's about 1. So 10, 1. So knowing a log looks like this, and it's going to come closer and closer, this we should know is going to asymptote here, just like the other did. Okay, you can always find what your base is by if this is 1 and it intersects at 10, then 10 is your base. Okay, so if I had a graph like this that asymptoted here, and this is 1, and this point was 4, then this would be log base 4 of x. Whatever your base is will have the y value of 1 as long as there's no shifts, no transformations, okay? Okay, so anyways, the reason why they're telling you to do this in your calculator, because your calculator is going to look like it's touching. It's not going to show the asymptote because it can't, okay? So we always tell you guys, double check your work in the calculator, but if you use your calculator to plot this, you're going to be coming straight out of the y-axis and going off to the right, okay? Instead of knowing that there is an asymptote, okay? Label the y, the x-intercept, we know that that's 1, okay? What is my domain? Well, my domain is always greater than 0, x greater than 0. My range is always all reals when it comes to those log questions, okay? Okay, so this one here, next one. Notice the asymptote is not at 0. It's shifted. 1, 2, 3. Here's my new asymptote, x equals negative 3. That means that there is a shift left 3. Well, there's only one over here or 2 over here that say shift left 3. Okay? Remember, when you're grouped with the x, you do the opposite. So this is shifting left 2. So that can't be it. This is shifting right 3. So that can't be it. So now you're down to 2. Okay? Both of them shifted down 1 with their numbers as well. Okay? So the easiest thing to do is to plot both of those in the calculator, take a look at your graph, okay? Or check points, okay? Here's a exact point right here. That's negative 2, negative 1. Here's negative 1, 0. Or here's 1, 1. 1, 1. No negatives, nothing bad to check, right? So if you plot those in or substitute those in here, you can see whether they work. So if I put a 1 equals log base 2 of 1 plus 3 minus 1. 1 plus 3 is 4. Log base 2 of 4 is 2, and 2 minus 1 is 1. There's our answer choice. Okay? Again, you could just type this in the calculator. Log base 3 of 1 plus 3. So log base 3 of 4. Well, you know that's a decimal because you can't raise 3 to an integer power to get 4. Okay, so that wouldn't have worked. Okay? All right. Next one, what is the domain? Well, up here it reminds you that the domain always has to be anything greater than 0. If it's ever negative or 0, it comes up impossible or error or undefined in your calculator. Because of this, we said it can never go past there unless there's a shift. So anytime you are asked to find the domain, we take whatever's inside here, and we know x is greater than 0 is what's supposed to be going on. Well, this whole thing is x in this problem. So we take this whole answer, 3x minus 4, set it greater than 0. We get 3x greater than 4. Sorry.
Mr. Creechy, Mrs. Shankar, please call the main office.
Okay, so my domain must be any number greater than 4/3, and it asked for set builder notation. That's what that is, okay? If you see it anywhere else, it's the set of x values such that x must be greater than 4/3. You've seen that before too, okay? All right, last thing. This is from Algebra 1. Okay, we want to show that it's always increasing, but we also want to check on an average rate of change. You know rate of change is slope. Average rate of change is just finding that average. So you find the change in y over the change in x. So you pick 2 points and you plug in the x value and find the y value for that x, and plug in another x value and find the y value for that x. So, set up and evaluate the expression for the average rate of change for this problem. They're wanting it over the interval of 1 to 10. So that's all we do, is we just plug in a 1 and a 10. Okay, so 10 minus 9, sorry, I said the answer. 10 minus 1 is 9, so I took 10, I took 1. Now I need to do f of 10 and f of 1, okay? And this is asking me to do it for a common log. So if I had f of 10 for a log base 10 of x, and x is 10, then this would be equal to 1. If I asked for f of 1 log base 10 of 1, well, what could I raise 10 to get 1? It would have to be 0. So 1 minus that is 1 over 9. Okay, so the average rate of change from 1 to 10 is just 1/9. Very low slope, okay? Now if they ask you to find the same exact thing for 1 to 100 as an interval, we do the same thing again. F of 1 is log base 10 of 1 is 0. 10 to the 0 is 1. F of 100 is log base 10 of 100. What would I need to raise 10 to get 100? 2, or just count your zeros, okay? So I have 100 minus 1 is 99, and I have 2 minus 0, so it's 2 over 99. So if this was a graph from 1 to 100, then I would be going only a slope of 2/99. Okay, so what can you tell about these two answers and the change of slope? Hopefully you realize that this is just showing you it's a very, very slow slope, very low, okay? Very small amount of change. And this is bigger than this. So the further you go, the slower it is going because it's exponential, okay? And we've talked about exponential. If you needed to check these two to compare them, you could put them in the calculator and check that. This is 0.1 repeating, and this is 0.02 repeating, okay? So you know which one is smaller, okay? All right, so Go back over anything that you need to. When you come in tomorrow, we are going to get into groups and work on our whiteboards to go through all of these to see how well you're doing it. I know several of you yesterday said it was pretty easy because it's really application of what you did last unit, so that's great, okay? All right, see you tomorrow.